Hello my dear students, welcome everyone to India's first animated live tuition. I welcome everyone to 90 plus my tuition app. Everyone keep your camera turned on. I hope you know the rules and regulations. So it's mandatory to keep your cameras turned on, guys. So everyone get ready for a brand new session with 90 plus my tuition app. Let's log on to the new chapter, right? Everyone who is like, yeah, we were there in the previous session with respect to the chapter light, isn't it? So please do let me know, guys, if you guys had some queries, concerns and all with respect to the portions which we covered in the previous session. Okay, I hope all of you are ready with your notes. I hope everyone is ready with your notebooks. So please do keep your notebooks ready. Let's learn the remaining portions, remaining concepts of the chapter light. So we were discussing the first part of it, right? So we were discussing the part of reflection. So let's check out more concepts in detail, okay? So let's learn about it. So today we'll have some ray diagrams in front of us. Kiran sir will be moving me to the middle and we'll be checking out the animations right away. Guys, you have to focus over here. You have the center of curvature over here. Let's check out the ray diagram. Let's check out the incident ray of light. So all those things we'll be checking out. Okay? So let's go ahead, guys. So is there anyone, any queries, concerns before we start? Hi Roshni. Roshni is like, sir, I'm there. Please do call my name. Yes, Roshni, go ahead.
Hi sir. So you have given us homework last time.
Yes. Yes. I do remember. So are you ready with it? Unmute Roshni.
Yes.
So you're ready with the homework, right, Roshni? So I asked you guys to do what? To fill this particular table, isn't it? Unmute Roshni. Roshni.
Yes.
So this was the homework, right?
Yes.
You guys did the homework or what? Yes, come again. Yes, unmute Roshni.
Yes sir, it's the homework.
Fine. So you have filled the table,
Yes sir.
drawn the ray diagrams.
Yes sir, ma'am.
So what are you gonna learn today? So it's just that, don't worry, you'll have a better understanding of the concepts, how the ray diagrams will come, how the incident ray of light will reflect. So all those things we'll be learning in detail today. Don't worry, you will have a better understanding of it. So for those who have done the homework, applause. Applause for everyone, those who have done the homework. So what you have to do, those who are ready with the homework, show your homework to the camera. Let me see how many of you have tried at least. Let me see. So Judy ma'am will be noting down the names, those who have done the homework. So we are checking who all are doing the homework, who all didn't even try. Some of you are sitting like this, sir. Yes, go ahead. We didn't do the homework. You guys did the homework, right? Fine, fine. Very good, very good. Okay, I can see you all. Yes, Ananya has hand raised. Hi Ananya, what's your concern?
Sir, this is my first class.
Okay, this is your first 10th grade session, right? You were there in 9th grade, I do remember.
Yes, sir.
Fine. So this year you have joined from the beginning itself, right? Previous year you joined in the middle, right? So don't worry. This year you'll get the detailed session of all the chapters, so you can learn all the concepts in a detailed, explained manner. So don't worry. So please do reach out if you have any concerns, queries, and all. Got it, Ananya?
Yes, sir.
So fine.
Sir, can I show this homework in the next class?
Sure. You were not there in the previous session, right?
Yes.
Yeah, it's okay. So for the missed session, what you have to do, you know what to do, right? Please do contact our academic counselor team. So from them, you will get the link. So with using that link, please do watch the session which you missed. It is mandatory. And guys, it's not like everyone can skip the classes. We'll use the links of the recorded sessions and we'll watch. No. You should provide a genuine reason. You should tell, sir, this is the reason I was not there in the previous session. This is why I joined late. This is the reason I skipped the previous session. So you should have a specific reason for it when you contact our academic counselors or teachers. Okay, then only they'll provide you the links. Got it, everyone? Nod your head. Clear? Clear? Don't say, sir, I'll go for some party and miss the session. I'll watch the recording. I'll be like, bye bye. Don't do that. Okay? So fine. So please take it seriously. So in the previous session, I told you something. Unmute Sania, Faisal. Guys, did I tell you when you are in the session, don't support your job? Sanya, do you remember?
Yeah. Yeah.
Then how? Why are you sitting like that? Why are you sitting like that? Sanya. Sanya is like, yeah, no sir, I just forgot it. Is it something like that, Sanya? Any genuine reason?
No, I just forgot.
Fine. So Sanya, did you do the homework? At least tried it?
Yeah.
Fine. Show it to the camera. Quick. Jody ma'am will be checking it. Sanya, close to the camera. We can't see it. We can't see what you have written. Keep it close to the camera. Where is the table? You didn't even spill the table, right? It's just blank. Only the first part is there. That particular particular example I have discussed in the previous session. So what have you tried, Sanya?
I didn't do it.
Okay, you said you have tried. So what you have tried? You tried looking at it or what? So by the next session, please do give a try. No excuses next time. Got it? Fine.
Okay.
So anyone who wants to answer? How many of you wants to answer? When we keep the object beyond C, what will be the position of the image? What will be the nature of the image? What will be the size of the image? Anyone who wants to answer? Roshni is like, I'll answer. And Leora D'Souza wants to answer. Who all wants to answer? Okay. Who was that? Amala and Raj, right? Amala wants to answer. A lot of students wants to answer. Fine. So what we'll do is we'll go one by one. You guys know it, right? Even if you are raising your hands, I won't call your name. I'm so rude, right? Anyways, so what I'll do, we'll check out each case one by one with perfect examples. Okay? Before we go with all these examples, let's go ahead. Let's learn the rules again. Guys, I hope you remember the rules. So let's check out the rules one by one. So Kiran sir will be showing us the rules one by one. So let's go ahead with the first rule. Okay, animation number 2. Yes. So Kiran sir will be placing me in the middle. Yes, Kiran sir. Please keep the diagram a little bit down. Yes, fine. So let's go, guys. Let's check out the rules one by one. I hope you remember it. Yes. So over here we are considering the concave mirror, right? We have the concave mirror over here, and what have we marked? We have marked the pole, we have marked the focus, and we have marked the center of curvature. So what we'll be doing initially, we'll be taking an incident ray of light from infinity, right? So that particular ray will be parallel to the principal axis. We have the principal axis over here, right? So the incident ray of light will be parallel to the principal axis, and what will happen? This particular incident ray of light will reflect. How it will reflect in the case of a concave mirror? It is a convergent mirror, right? So you know what will happen? The ray of light will deflect or will reflect or converge inside, right? So it will pass through the focus. So over here you can see that the incident ray of light, the parallel ray of light is reflecting through the principal focus. So this is the first rule. So from this rule, what can we understand? That is, if there is an incident ray of light which is parallel to the principal axis, it will reflect back through the principal focus. Okay? In front of the mirror itself. Is it on the rear side? No, right? This is the rear side of the mirror. This is the front side. It is marked, right? Lines, can you see? This is the rear side. This is the front side of the mirror. So the image is formed in front of the mirror itself, right? So when a ray of light, if a ray of light is incidenting parallel to the principal axis, obviously we know that it will reflect back through the principal focus. Guys, are you able to see it? Clear, everyone? This is the first rule which we learned in the previous session. So let's check out the next one. Kiran sir is ready with the next one. Let's check out the next rule. Guys, one by one, register the rules in your mind. Only if you know the rules, then only we can proceed with drawing each ray diagrams with specific position of the objects. Got it? Fine. Yes, Kiran sir. So please play it. Yes. So here we are considering an incident ray of light passing through the principal focus, and what will happen? The reflected ray will pass parallel to the principal axis. So in the first rule, in the initial case, what was happening? The incident ray of light, when it was parallel to the principal axis, the reflected ray went through the focus. Now, when the incident ray is passing through the focus, the reflected ray is parallel. It is just contradicting with each other. Got it? Contradicting with one another. So over here, you can see that when a incident ray of light is passing through the principal focus, it is reflecting back parallel to the principal axis over here, as you can see. Understood, everyone? Got it? Clear? Nod your head like a puppet. Fun. Everyone, thumbs up. I hope you remember the rules which we learned in the previous session. Yes, let's go ahead with the next rule. Yes. So in the case of a concave mirror, what will happen? Yes, Kiran sir. Yes, convex, yes. Yes. Over here, in the case of a convex mirror also, what is happening? When an incident ray of light is incidenting. Yes, Kiran sir, go ahead. So imaginarily we can see that it is incidenting through the principal focus, right? So what is happening? It is reflecting back parallel to the principal axis. Got it? It is reflecting back parallel to the principal axis. When the incident ray of light is passing through the principal focus, it is reflecting back through the parallel to the principal axis in the case of a convex mirror as well. In the case of a concave mirror, it was the same. In the case of convex mirror also, it is the same. It is just that we are considering the principal focus imaginarily behind the mirror, that is on the virtual side. Got it? So over here, the reflected ray is reflected in front of the mirror itself, which is parallel to the principal axis if the incident ray is imaginarily or appear to pass through the principal focus. Can you see over here when the incident ray comes all the way like this, it is passing through the principal focus over here, as you can see. Now what is happening? The reflected ray is passing like this. Can you see? It is parallel to the principal axis, right? It's parallel over here. And the incident ray of light is passing through the principal focus over here. Got it, everyone? Understood? Fine. So yes, Kiran sir, let's go ahead with the next animation. Fine. Now in this case, let's see what happens when we are considering a concave mirror. When the incident ray of light is incidenting through the center of curvature, what will happen? You know it, right? Obviously, the incident ray of light will reflect back, as you can see over here. It is reflecting back through the same path, right? In the case of the center of curvature, that is, if the incident ray is passing through the center of curvature, in the case of a concave mirror, it will reflect back through the center of curvature itself. Got it, everyone? This is the next rule which we learn. In the case of a convex mirror as well, it is the same, right? Let's check it out. Yes, Kiran sir. Let's go ahead with the next animation. In the case of a convex mirror, let's see what happens. When we are considering an incident ray of light which is passing through the center of curvature, which appear to pass through the center of curvature, right? What will happen? This incident ray of light will reflect back through the same path itself. Can you see, guys? Over here, can you see? The incident ray of light appear to pass through the center of curvature. Then what will happen? This incident ray of light will reflect back through the center of curvature itself. Got it, everyone? So it is the same as in the case of concave mirror. In the case of a convex mirror also, it is the same. Got it? Don't get confused with it. So the first two rows, the contradicting one, you guys can remember, right? So this one also, please do remember it. And you don't have to number it as rule number 1, 2, 3 and all. Just for your understanding, you can number it. Rule 1, rule 2, rule 3 and all. There is no particular numbering system and all with respect to the rules to remember for studying image formation. You can name the rule according to your wish. Got it? Just for your understanding, you can name it as rule number 1, rule number 2, rule number 3 and all. Okay? So today we have recalled the rules which we have discussed in the previous session already. So the first two you can relate, right? Contradicting. and in this case it was the when the incident ray of light when it was passing through the center of curvature, it is reflecting back to the same path itself, right? Now let's check out the next rule. Yes. Then in the next case, the case of a concave mirror, if we are considering an incident ray, yes Kiran sir, when we are considering an incident ray of light, when it is passing through, when it is incidenting to the pole, what will happen? It will make the same angle with respect to the principal axis. That is, the angle of incidence and angle of reflection will be equal with respect to the principal axis. Please don't forget. When we are considering the angle over here, can you see the angle over here? The angle over here will be the same with respect to the angle over here, which means the angle of incidence with respect to the principal axis will be equal to the angle of incidence with respect to the principal axis, angle of reflection with respect to the principal axis. So angle of incidence and angle of reflection will be the same. In the case of a concave mirror, there is the next rule. What about the case in the case of a convex mirror? Case of concave mirror, we have understood if there is an incident ray incidenting to the pole, it will make the same angle. In the case of a reflecting ray as well. What about the case of convex mirror? Any ideas, guesses? Everyone knows it, right? We have discussed this already in the previous session, so we can understand that in the case of a convex mirror as well, it will be the same, right? Let's check it out. Yes, Kiran sir. So when we are considering an incident ray of light incidenting to the pole, what is happening? It is reflecting back, making the same angle with respect to the principal axis. So the angle of incidence and angle of reflection will be the same over here, as you can see. So what is happening over here? Same angle with respect to the principal axis. What is happening? The incident ray is incidenting on the pole of the convex mirror over here. In the case of concave mirror as well, it was the same. Clear, everyone? Let me know whether it's clear or not, all the four rules. In case of convex mirror and concave mirror, it was the same, right? So we were checking out the animations, we were discussing all these concepts in the previous session. So those who remember, those who recall, give me a thumbs up. And those who were not there, if you have a query with respect to the rules, please do let me know. Any concerns, queries? Fine. So everyone understood? Fine. So let's go ahead, guys. Clear, right? Clear for everyone, right? Fine. Now, let's check out the homework. Guys, do you remember this particular case where we have considered the position of the object at infinity, beyond C, at C, between C and F, at F, between F and the mirror? In the case of between F and mirror, we can write as between F and P or the pole. F and mirror means F and pole, right? F means what? The principal focus over here. Fine. So in the first case we have discussed already, right? The case of at infinity. When the incident ray of light is coming from infinity, obviously the incident ray of light will be parallel to the principal axis. So it will make a point-sized, highly diminished image at the principal focus. And the nature of the image will be real and inverted. We have checked this out already in the previous session. I hope you might have drawn the ray diagrams as well. Guys, have you drawn the ray diagram? The case of infinity, did you draw it? If you didn't draw it in the previous session, I will give you time. Go ahead. Draw the diagram in the case of at infinity. What will happen if a ray of light is coming parallel to the principal axis? What will happen? It will pass through the principal focus, as you can see here. Okay? So please do draw it. So in the meantime, Kiran sir will be making me invisible. So once you're done, give me a thumbs up. guys done? Give me a thumbs up once you're done. Then only I'll come back. Fine. Okay, everyone is giving thumbs up. Let's come back. Fine. So some of you were asking, so what is principal axis? We have checked out the terms already in the previous session, right? You guys forgot it or what? Terms associated with spherical mirrors. We have checked all these terms, right, in the previous session. Straight line connecting the pole and the center of curvature. So here we are considering the pole, right? So there is a line connecting the pole and center of curvature. So the center axis is which we consider, which connects the center of curvature and the pole, is termed as the principal axis. So please do let me know. Those who asked, did you understand? Karthikeyan, right? Karthikeyan, did you understand? Raise your hand or type okay or yes in the chat box, or raise your hand, let me know. Karthikeyan, where are you? Yes, Karthikeyan, unmute yourself. Karthikeyan Prabhu.
Yes.
Fine, you got it, right? So Karthikeyan, why your camera is turned off? Let me know what's your concern. Please keep it turned on. Keep your camera turned on. Fine. So you guys have drawn the diagram in the case of infinity, right? I hope you guys are ready with it. Let me know. Fine. So in the case of at infinity, we have seen the animation already, right? So you guys want the animation again? You want to check out the animation again? You want to see? Fine. So most of my students wants the animation again. We'll check out case of infinity. Yes, Kiran sir, the 10th animation. Yes. In the case of infinity, what will happen? Let's check out. Yes. So based on the rules which we have learned, we can understand it, right? Very easy. Yes. And we are considering incident rays of light coming from infinity. So it is incidenting parallel to the principal axis over here, right? Can you see, guys? Kiran sir, can you make me a little bit bigger? Yes. So everyone is like, yeah, lines on top of me. So we'll check it out. Yes. Guys, can you see over here? We can see, right? We can see the lines, incident ray of light coming parallel to the principal axis. Isn't it? Then what is happening? It is incidenting parallel. Then what will happen? Let's check it out. In the case of reflection, yes, it is reflecting back through the principal focus. It is reflecting back through the principal focus. In the case of a concave mirror, we have learned already. In the case of concave mirror, it is a convergent mirror. So over here, the rays are converging through the principal focus. So since the image is formed at the principal focus, what type of image? It will be highly diminished point-sized image. That will be the size of the image. And what about the nature? In the case of the image formation in front of the mirror itself, what will happen? What about the nature? It will be real image, right? Since the image is formed in front of the mirror itself, so it will be real image. And in the previous section, we have learned that in the case of real image, it will be inverted for sure. Real and inverted will be connected all the time. So with that logic, you can understand. If you get that the image is formed in front of the mirror, so it will be real. So you can relate it. So you can understand. In the case of a real image, obviously it will be inverted. So the nature of the image will be real and inverted. And with respect to the position of the image, where is the position of the image? Everyone in the chat box, what about the position of the image? Where is it formed? In the chat box, let me know. Everyone, at focus, at principal focus, at F. Yes, very good guys, very good. So all of you are responding. The image is formed at F. So in the case of infinity, the image is formed at F. The nature of the image is real and inverted. Yes, Kiran sir. The size of the image will be point-sized or highly diminished. Now, in the case of beyond C, what do you think, guys? In the case of beyond C, what about the position of the image? Will it be at F? Will it be real and inverted? Will it be highly diminished? So let's check out in the case of beyond C, what will happen? So let's go ahead. In the case of beyond C. So here you can see that when we are considering an incident ray of light incidenting parallel to the principal axis, it will pass through the principal focus, right? But what are we doing? We are keeping the object beyond C. We are keeping the object beyond C, so we need to consider another incident ray of light like this. Then only we can form the incident ray of light. We can form the image, right? With respect to one single incident ray of light, we can't form the image, right? So what are we doing? We are considering two incident rays of light. One is incidenting parallel to the principal axis, and one ray of light is passing through the center of curvature. So with respect to the rules we have learned, when the incident ray of light is passing through the center of curvature, it will reflect back to the same path itself, right? Isn't it? So let's check out the animation of, in the case of beyond C. So Kiran sir is ready with the animation. So let's go ahead with it. Yes, Kiran sir. Yes. So we are keeping the object beyond C over here. Okay. Now let's consider, and yes, Kiran sir. Now let's consider an incident ray of light passing parallel to the principal axis and another incident ray of light which is passing through the center of curvature. And what you have to do, guys, I told you, if you learn the rules, what will happen? We can apply in the case of image formation. So over here, we have to apply two rules. The first one, when a ray of light is incidenting parallel to the principal axis, it will pass through the principal focus. Then the next rule, what we have learned, when there is an incident ray of light which is passing through the center of curvature, obviously it will reflect back through the same path itself, as you can see here. So let's check out. Yes, Kiran sir. So here we are applying the rules, right? So with respect to the rules, we can understand how the reflected ray will come in these two cases. So in the first case, it is passing through the principal focus, since the incident ray is parallel to the principal axis. Then in the next case, since the incident ray is passing through the center of curvature, we can see that it is incidenting back through the same path itself. So here the image is formed. Can you see, guys? Over here the image is formed. When the incident ray of light is coming like this, another incident ray of light is coming like this. So with respect to these two incident rays, with respect to these two reflected rays, we can see the image is formed over here. Isn't it? So what are we doing? We are applying the two rules over here. Is it just one rule over here? No, right? We are considering two rules over here. We are considering one single rule in this case, where the incident ray of light is parallel to the principal axis in this case. And what will happen? We'll consider that the reflected ray will pass through the principal focus, as you can see here. Then in the next case, when we are considering the incident ray of light passing through the center of curvature, what will happen? It will reflect back through the same path itself, as you can see here. So we are applying two different rules in one single ray diagram, or in the case of one single image formation. The only thing which you have to register in your mind, what is that? It is none other than we are keeping the object beyond C. Got it, everyone? Object is kept beyond C. So we are considering two incident rays of light. Then we will get the image formed between C and F, right? So we are getting the image formed between C and F. What about the nature of the image? You guys know it, right? Over here you can see that the image is inverted. It is upside down, right? Can you see, guys? The image is inverted upside down. So obviously the nature of the image will be real and inverted. What about the size? It is diminished, right? So there is a particular size, but it is diminished, not highly diminished or point size. It is just diminished. So let's fill the table, guys. Yes, Kiran sir. Yes. So in the case of beyond C, we have checked out the ray diagram. What you have to do, guys, those who wants to draw the ray diagram, please draw it first, then we'll fill the table. So get ready with the ray diagram, important, mandatory. So step by step, at infinity, beyond C, at F, between C and F, in all these cases you have to learn where will we get the image, what will be the nature of the image, what is the size of the image. All these things are mandatory and important. Please do draw this ray diagram. Once you are done, please do let me know. Priyanka, are you drawing the ray diagram? Where is your ray diagram? Unmute Priyanka. Priyanka. Hi Priyanka, why are you not unmuting yourself? Not working? What is not working? Priyanka.
I think she is having trouble hearing you.
Okay, Priyanka, where's your ray diagram? Show me your notebook to the camera. Priyanka, board to rate.
Sir, I can't hear you.
You can't hear me or what?
Sir?
Yes?
Sir, I can't hear you.
Okay, without hearing my voice, how can you understand the session? Let me know your concern. Guys, you guys can hear me or what? Everyone can hear me properly, Priyanka. What's your concern? Okay, Priyanka, do one thing. Fix earphones or headphones. Maybe you might be having some trouble with the audio. So what you have to do, please do type it down, Judy ma'am. So Priyanka is saying she is hearing the voice broken voice, right? It'll be your network. So what you have to do, Judy ma'am, please type it in the chat box. Priyanka, you'll be getting the instructions, don't worry. Priyanka is like, sir, I can't hear you, don't give me instructions. You'll get the instructions in the chat box, fine. So guys, everyone done drawing the ray diagram? Let me know once you're done with the ray diagrams. Fine. Yes. Priyanka is like, sir, I will try to restart my laptop. Yes. So guys, once you're done drawing the ray diagrams, what you have to do? Lift your notebook to the camera and let me see. You guys are drawing the ray diagrams and all. Let me see you guys are doing it. Done, everyone? Some of you were asking, what does diminished means? So over here, what about the object size? Guys, can you see the object size? Okay, object has a particular size, right? But what about the image form? Image form, the size of the image form is short, right? So the size of the image is diminished, which means the size got reduced, shorter image, that is diminished image. It's not the exact actual same size as of the object, right? So the image which we are getting over here is diminished, means it became a little bit shorter. It got diminished down. Got it? So that is the meaning of the term diminished. Understood? Who was that?
Haya.
Haya Fatima, got it? Type yes or no in the chat box or raise your hands and let me know. Haya Fatima, did you understand? Yes, Judy ma'am. Okay, fine. So guys, done with the ray diagram, ready with it? So one important thing, when you draw the ray diagrams, what you have to do? Please do use a ruler. Don't draw the ray diagrams like this. Okay, fine. So incident ray of light, reflected ray of light. Will you understand anything? No, right? So please don't draw it roughly. What you have to do? Use a ruler. So draw it perfectly. You have to mark where we have kept the object, that is beyond C, right? So over here you can see, you can find the center of curvature C. So we are keeping the object beyond C. Then we are considering the incident rays of light which is parallel to the principal axis and a ray of light which is passing through the center of curvature. Then we can see the ray of light which is passing through the center of curvature, it is reflecting back through the same path, and the ray of light which is parallel is passing through the principal focus. Then we can see the image which is formed over here. So all these things should properly marked on your diagram. Got it? And please do mark the Paul P as well. Paul P, the principal focus F, and the center of curvature C. All these things, please do mark it. It is important and mandatory. Once you're done with it, please do let me know. Let me know once you're done with it. Ready, everyone? Can we go ahead? Fine. So let's check out the next case. So the next case. So in the case of beyond C, what about the position of the image with respect to the ray diagram, guys? It is, the image is formed between C and F, right? The image is formed between C and F. So with respect to the position of the image, it is between C and F. Now, with respect to the nature of the image, it is real and inverted. With respect to the size of the image, it will be diminished. Diminished, real and inverted between C and F. I hope you understood all these three cases. Now, let's check out what will happen if we are keeping the object at C. What about the position of the image? What about the nature of the image? What about the size of the image? Let's check out what will happen if we are keeping the object at C. So Kiran sir is ready with the animation. Yes, Kiran sir. So here we can see that you guys can see it, right? We are keeping the object at C. So here we are keeping the object at C. Let's consider the incident rays of light. Now we are considering an incident ray of light which is passing parallel to the principal axis, and another incident ray of light we are considering which is incidenting to the pole. And what you have to do? You have to apply two rules in this case as you have learned. Yes. Go ahead. So let's see what happens. The case of the first case, the incident ray of light will pass through the principal focus, right? We know it already. Then in the next case, if the incident ray of light is incidenting on the pole, what will happen? It will reflect back, making the same angle with respect to the principal axis. Got it? So the angle of incidence and angle of reflection over here will be the same. Got it? Then if we are considering the incident ray of light parallel to the principal axis, what will happen? It will pass through the principal focus itself. Got it? Now what will happen? The image will be formed right away at C itself. Can you see, guys? These two reflected rays are incidenting over here. Got it? So in this particular position, we will get the image. So the image is inverted, right? Can you see the inverted image over here? So this particular thing is the object, just marked over here, and this particular part is the image. Got it? Object and image. Got it? Now the image, what about the image? It is real and inverted. Can you see it is upside down? So it is inverted. So what about the nature of the image? It is inverted. What about the size, guys? With respect to the size of the object and image, is there a difference in size? Let me know. Is there a difference over here with respect to the object and the image? Can you see a difference over here? Let me know in the chat box. What about the size of the image? Is it the same or different? Let me know, guys, real quick. Everyone is responding. The size will be the same, right? It is the same over here. As you can see, the size of the object and the size of the image is same over here, as you can see, and the object is kept at C and the image is formed at C itself. And the nature will be real and inverted, and the size will be same. So let's fill the table. So in the case of Beyonce, we have learned, and with respect to HC, we'll get the ray diagram like this. First draw the ray diagrams, then we'll fill the table. So we are considering an incident ray of light which is passing parallel to the principal axis, and it is reflecting back through the principal focus. And the next ray of light we are considering which is incidenting on the pole, and it will reflect back, making the same angle with respect to the principal axis, as you can see here. So draw the ray diagram in a neat manner, guys. Important and mandatory. Then after that, we'll fill the table. Let me know once you're done, guys. Everyone done or what? Once you're done, give me a thumbs up. Or if you have any query, do raise your hands. Ask me, sir, I didn't understand. I have a query. And some of you are typing 1 second. Okay, 1 second done. Can I go ahead? Done. Fine. Rihan, did you understand? Fine. Rihan already giving double thumbs up. Hi, Mohammed. Yes, unmute Mohammed. Let me know. Let me know. What's your concern, Mohammed? Yes, Judy ma'am. Yes, let me know your concern in the chat box, Mohammed. Type it down in the chat box. Mohammed, can you please raise your hand? If you still have a query, please do raise your hand. Yeah, fine. Yes, Judy ma'am, please do unmute Mohammed.
So in this, the object is at C, right? It's not between C and F.
Yeah, object is at C. Who said it is between C?
So in the question, it says between C and F.
Between C and F? No. It is at C. Between C and F is in the previous case, Mohammed. This is the previous case, between C and F. We are considering the question at C itself. This is the case which we are discussing. This is the case at C. The object is kept at C. Between C and F is the next case. So you'll learn about it in the next case. That is the next case. Can you see between C and F? This is the next case. Got it?
Yeah.
Fine. So in the case of object at C, we'll get the image at C itself, and the size of the image will be the same, and the nature of the image will be real and inverted. So please do fill the table as well, guys. Yes, Amelia. Hi, Amelia.
Hi, sir.
Yes, what's your concern? Go ahead.
For the position of the object at C,
Yes.
in my notebook, the second ray which you have shown here is passing through P and is the reflected ray, the incident ray and reflected ray is equal, whereas but in my notebook it passes through the principal focus but not at P.
Over here, the incident ray which is passing parallel to the principal axis is passing through the principal focus itself. But the incident ray which is incidenting at the pole won't pass through the focus. How it will happen? Will it go like this? No, it is not possible. So you should correct what is drawn in your notebook. Got it?
Yeah.
Yeah. If it is drawn like this, it won't happen. If there is an incident ray which is incidenting on the pole, so based on the rules which we learn, we know that it will reflect back, making the same angle with the principal axis. Can you see over here, Amelia? Understood?
Yeah.
Please do apply the rules which we learn. So this is how we'll get the ray diagram. And with respect to the position of the object at C, we'll get the position of the image at C itself. And the nature of the image will be real and inverted, and the size of the image will be same size. So please do fill the table. So those who have done the homework is like, yeah, we know the answers, fine. Roshni is laughing, fine. So we'll go ahead. The case of between C and F, if we keep the object between C and F, what will happen? So Muhammad was asking, sir, what will happen if we keep the object between C and F? So let's check out that case. I hope you're ready. So imagine we're keeping the object between C and F. So let's check out what will happen in this case. Yes, Kiran sir. Yes. If we are keeping the object between C and F, what will happen, guys? Let's see. Yes, Kiran sir. We are considering keeping the object between C and F, and we are considering the incident rays of light passing over here parallel to the principal axis, and the next ray of light we are incidenting to the pole. So as you can see here, and what will happen? This incident ray of light will reflect back, making the same angle, right? Isn't it? Then this incident ray of light which is parallel to the principal axis will pass through the principal focus itself, as you can see here. Can you see, guys? The incident ray of light which is passing parallel to the principal axis is passing through the principal focus itself. Understood, everyone? So over here, the image will be formed beyond C. The image is formed beyond C. Got it? Yeah. Who was that? Some of you still have query with the object at C. Yes, Shaniel, unmute yourself. What's your concern? Okay. Yeah. Who was that?
And Shaniel.
Anish, yeah, Anish, Daniel, please do raise your hands or let me know where did you understand, where you didn't understand which part. So guys, what you have to do is, I'll be asking, right, guys, did you understand? Can I go ahead? So in that case itself, you should let me know, sir, we didn't understand. So before going ahead, let's discuss this again. So at C, okay, some of you wants just the diagram, ray diagram, right? Anyways, I'll explain it again. What are we doing in the case of HC? We'll check out the animation as well, so you'll have a better understanding. Kiran sir, can you please play the previous animation? Yeah, HC, the previous animation. Yes, this one. So guys, yes, Kiran sir, please move me as well. Okay, this is fine, this is fine. So over here, can you see guys? We are considering the incident ray of light parallel to the principal axis, right? So based on the rule number 1 which we learned, what will happen? The incident ray of light which is passing parallel to the principal axis will pass through the principal focus, right? Will pass through the principal focus. Then the next incident ray of light which is incidenting on the pole will reflect back, making the same angle with respect to the principal axis. So if we are considering the incident ray of light which is passing through the principal focus and the next one which is making same angle with respect to the principal axis, it will go like this. And these two rays of light will incident over here. Why? Since we have kept the object at C. Since we have kept the object at C, the reflected rays are going like this. So we are getting the image at C itself. So this is the case of at C. So this is how we will get the ray diagram. Yes, Kiran sir, keep it there. Unmute Shaniel. Shaniel, understood? In the case of HC, clear? Fine. Yeah. Manish, right? Understood, Manish? Let me know. Any confusions?
Yes, ma'am. I mean, yes, sir.
Yeah, yes, I mean, yes, sir. Yes, ma'am. Fine. So you got the concept, right? That is our prime concern. Clear?
Yes, sir.
Fine.
Yes, sir.
Yeah. So we'll go ahead with the next case where we'll keep the object between C and F. So let's consider case of between C and F. Yes, Kiran sir, please play the next animation between C and F. Let's check it out, guys. Yes. When we are considering the incident ray of light which is parallel to the principal axis, as you can see here, what is happening? We have learned with respect to the first rule, the incident ray of light will pass through the principal focus itself. Can you see, guys? Can you see over here? Now, the next ray which we are considering, which is incidenting to the pole, it will reflect back, making the same angle with respect to the principal axis. So, guys, you will be thinking, in the previous case also, we have considered two incident rays. One was parallel to the principal axis and one was incidenting to the pole. And why the image is not formed at C? In the previous case it was the same, right? But in the previous case the object was kept at C. So in this case we'll get a smaller ray of light, right? So the image will be formed over here. Since these two reflected rays will be incidenting over here at C. But in this case, we are keeping the object between C and F, as you can see here. Since we are keeping the object between C and F, as you can see here, what is happening? The reflected rays will form the image beyond C over here, as you can see. Understood? Just because we are keeping the object between C and F over here, we are getting the image beyond C. Got it? So in the first case, not in the first case, at C, in that case, what we were doing? We were keeping the object at C itself, right? So that's why we were getting the image at C itself. But in this case, what is happening? We are keeping the object between C and F. So what is happening? We are getting the image beyond C, as you can see here. Understood, everyone? Clear? Fine. So let's okay, before we go with the ray diagram, let me know anyone who didn't understand between C and F how the image is formed over here. Got it? Fine. So let's draw the ray diagram, guys. Please do draw this ray diagram. When we are keeping the object between C and F, what is happening? The reflected ray will go like this and the image will be formed beyond C, as you can see here. So please do let me know if you have some concerns, queries and all. Please do let me know. So one of you is asking, for exam, will they give some information about the table and rest we have to fill like this? Questions will come. Yes, will be there. So for example, you'll have questions like this. You'll just have the table. So it'll be the position of the objects will be given. So you have to fill. What about the nature of the image? What about the position of the image? What about the size of the image? All these things you have to fill. Or else you will have a particular question which will be asked directly. What will happen if we keep the object at C in the case of a concave mirror? So we are learning the image formation in the case of a concave mirror, right? So you should be aware what will happen if we keep the object at C in the case of a concave mirror. How will we get the image? So you'll be asked to draw the ray diagram as well. So you will be asked to draw the image formation ray diagrams. So you have to learn the ray diagrams as well as we are discussing the ray diagrams as well, right? So this is the ray diagram. If we keep the object between C and F, as you can see here, you should know if we are keeping the object between C and F, how we should draw the incident rays of light, how we should mark the reflected rays, how we should mark the image formed or the position of the image. So all these things you should know. So from this ray diagram itself, you can understand, right? Over here, the image is formed as real and inverted, right? The image is formed as real and inverted. Got it? It is upside down, right? The image is upside down. What about the size, guys? Is it the same size as of the object? The size of the image, is it the same as of the object? Let me know, everyone. Is it the same or different? Type it down in the chat box. Is it the same or different? Let me know real quick. What about the size of the image? Nature I have already discussed, real and inverted. The image is, the position of the image I have discussed, it is beyond C, as you can see here. The image is formed beyond C for sure. Now let me know the size of the image formed. It will be diminished or highly diminished or same size or enlarged. So all of you are typing the right answer. The size of the image will be enlarged, isn't it? Yes, bigger than the object. Very good. Yes, Bhagat Suresh, what's your concern? Type, unmute yourself.
So, for my image, I kept the distance between C and P as 2 centimeters, and the distance between C and F as 1 centimeter. But when I drew the ray diagram, I got the image to form after C.
So yeah, after C, there is beyond C. In the case of between C and F, the image will be formed beyond C itself.
No, I found between C and F itself, like right before C.
Okay. So in the case of in general case, you don't have to measure 1 centimeters, 2 centimeters and all. It's just that your center of curvature should be double the focal length. Got it? So if you are measuring, if you are keeping a particular value for focal length or F, so if you are drawing with values, what you have to do? Draw the center of curvature, double the focal length. That we will learn. So it will be 2F. So please draw it like this. Then only you will get the image beyond C. Got it? So Bhagat Suresh, what you have to do? In the case of these such ray diagrams, these are rough ray diagrams, right? We are not marking the values and all. So with respect to values, we don't have to draw it right now. So what you have to do? With respect to general case, you have to keep the object between C and F, and the image will be formed beyond C. With respect to that, you have to draw. Got it, Bhagat Suresh?
Okay.
And if you wish to keep values, you can do it, but still, what you have to do? Keep the measure of center of curvature as double the length of this focal length. Got it? Then only you will get the perfect image beyond C. Clear?
Okay.
So please do let me know, guys, once you're done with the ray diagram. Can we go ahead? Can we go ahead? Everyone making faces, sir, we got it or we didn't get it. So once I go ahead with the next next position of the object, don't say, sir, we didn't understand between C and F. So you can say it right away. So I need a better explanation or clarity. So let me know. No, right? So let's go ahead. When we are keeping the object between C and F, what will happen? We'll get the position of the image beyond C. The nature of the image will be real and inverted, and the size of the image will be enlarged. Now, at F, if we are keeping the object at F, what will happen? Any guesses, guys, before we go to the ray diagram or animation? Any guesses in the chat box? If we're keeping the object at F, where will we get the image? What about the position of the image? Let me know, everyone. What about the position of the image if we keep the object at f? If we are keeping the object at f, where will we get the image? I want the responses from everyone. Everyone should respond in the chat box. Quick. Lot of responses coming up. Very good, guys. I appreciate it. So should I reveal the answer right away, or should I show the ray diagram? Okay, some of you are typing the wrong answers as well. Between C and F. No, not between C and F. If we keep the object at F, let's check it out. Kiran sir is ready with the next animation. Let's check it out, guys. Yes. So over here, what is happening? When we are considering the object at F, what is happening, guys? Yes, Kiran sir. So what is happening? We are considering the incident rays of light which is parallel to the principal axis, and the next incident ray of light, what is happening? We are considering it as incidenting to the pole. So you know how the reflected rays will go, right? So just apply the rules. If the incident ray of light is parallel to the principal axis, obviously it will pass through the principal focus, as you can see here. Now the next ray of light which is incidenting the pole, it will pass by making the same angle with respect to the principal axis. That is, the angle of incidence and angle of reflection will be the same over here. So what is happening, guys? These rays of light are going parallel, right? The reflected rays are going parallel. So will we get an image anywhere over here? We'll get the image at infinity, right? So we'll get a slanted image, not a proper image. We'll get the image at infinity. And what about the nature of the image? Since the reflected rays are going down the line, right? Down this principal axis, not above it. So it will not be erect, it will be inverted, right? It will be real and inverted. Everyone, very good, very good. Everyone is typing down the chat box. The nature of the image will be real and inverted. And what about its size? Any guesses? What about its size? Yes, Roshni has some queries. Unmute yourself. Yes, some of you are typing. The size will be highly enlarged since the image is formed at infinity, right? So let's check it out. Yes, Roshni, unmute yourself. What's your concern? Judy ma'am. Roshni, you wanted to answer or you have a query? Okay, you accidentally raised your hand or what? Yes, Judy ma'am. Accidentally raised your hand, so what? Fine. So guys, understood? If we are keeping the object at F, what will happen? We are considering the incident rays of light which is passing parallel to the principal axis, as you can see here, and the reflected ray will pass through the principal focus. And if you are considering the incident ray of light which is incidenting the pole, it will make the same angle with respect to the principal axis. Okay, so the angle of incidence and angle of reflection will be the same. So these two reflected rays will go parallel to each other, as you can see here. So in this case, the image will be formed at infinity, and the nature of the image will be real and inverted, and the size of it will obviously be highly enlarged, right? So a lot of responses coming up. Yes, Kiran sir, you can remove the animation. So let's go ahead, guys. The case of at F, the position of the image will be at infinity, the nature of the image will be real and inverted, and the size of it will be highly enlarged. So please do fill the table. So let's draw the ray diagram as well. Please draw the ray diagram as well. Important. Yes, Suraj, unmute yourself. What's your concern? Go ahead.
So if both the reflected rays are parallel, does that mean it's formed at infinity?
Yeah. So it is just that we are considering the image formation in the general context, right? So since both of them are passing parallel to each other, so there is no. So as you can see here, there is no possibility for them to intersect at any particular point, right? So what we'll do, we'll assume the image will be formed at infinity, which means practically if you do it, you won't get a proper image. Got it? It'll be blurred and all. Why? Because the image is formed at infinity. So can you go to infinity and try? It will be tough, right? Practically not possible. So what we'll assume? We'll assume the image to be formed at infinity. Got it? So in the first case also, when the incident rays of lights was coming parallel to the principal axis, what was happening? We are keeping the object at infinity, right? But practically, if you think, can we keep the object at infinity? We're just assuming we are keeping the object at infinity, and the rays of light is coming parallel to the principal axis. Got it, Suraj? Fine, very good. Glad that you asked. So everyone's query is clear. So guys, please do reach out if you have such queries. So what you have to do, please do draw the ray diagrams. Once you're done, give me a thumbs up. So in the meantime, Kiran sir will be making me invisible. Once you're done with it, you should give me a thumbs up. Then only I'll come back. Okay? Everyone done? No thumbs ups coming up? Only if thumbs ups are coming, I'll come back. Okay, everyone is like, we won't give thumbs up, you don't come back. You just stay there so that we won't have the session, right? You guys want to learn or what? So let's go ahead, guys. Everyone is giving thumbs up. I'm so glad. Yes, Kiran sir. Fine. So everyone done with the ray diagram? Fine. So let's check out the next case. So next case will have a twist, right? Everyone knows the twist or what? So till now, we have understood the case of keeping an object at infinity, beyond C, at C, between C and F, and at F. We got the nature of the image as real and invert. Will it be the same in this case as well? Will we get the image like this? Or will we get the image in all the same position or a different position? What about the size of the image? Will it be highly enlarged or same size and all? Let's check it out in the case of between P and F. Everyone got the answer? What? The image will be formed behind the mirror. So you'll be thinking, what will happen? How is it possible? Behind the mirror. Till now, we got the image at F, between C and F, at C, beyond C, at infinity and all, right? But the nature of the image was real and invert, which means all the images formed was in front of the mirror itself. But in this case, between P and F, why are we getting the image behind the mirror? Behind the mirror means what? The nature of the image will obviously be virtual and erect. And what about the size of the image? So let's check it out. So we'll check out the animation of it. Then only you will understand. Yes, Kiran sir. We'll go ahead with the next example. So what are we doing over here, guys? We are keeping the object between P and F. Can you see over here? We are keeping the object between F and between P. So we are keeping the object over here. Now let's consider the incident rays. Yes, Kiran sir. So here we are considering the incident rays of light. So what are we doing? One particular incident ray which is passing parallel to the principal axis, and the next ray of light which is incidenting the pole, right? So we know what will happen. If an incident ray of light is passing passing parallel to the principal axis, what will happen? Obviously, it will pass through the principal focus. Then the next case, with respect to the incident ray incidenting on the pole, it will make the same angle, right? It will make the same angle. So what will happen? The reflected ray will go like this. And over here, the incident ray which is passing to the principal focus will go like this. Is it possible for us to form an image over here, guys? So these two reflected rays are going according to their wish. One ray is going like this and the other one is going like this. So consider this particular ray of light is Manish, and let's consider this particular ray of light is Shamil, right? So Manish is going according to his wish and Shamil is going like this. Not fair enough, right? They both are fighting, I guess. So here, is it possible for them to make an image? They won't get a good image if they are fighting, right? So since Manish is going the other way and Shamil is like this. Shamil is drinking water, so please don't call my name. So guys, over here, is it possible to make the image in front of the mirror? It is tough, right? We can't get the image over here, right? Since both the reflected rays are going according to their wish. But why? Because we are applying the rules, right? If the incident ray of light which is passing through the principal axis, passing parallel to the principal axis, will reflect back to the principal focus. So it is going like this. Now the next ray of light, this incidenting to the pole, it will make the same angle with respect to the principal axis. So if it is making the same angle, it will go like this. Because we are keeping the object between F and P so close, right? So it will make a bigger angle over here. So these two reflected rays are not parallel. What are they? They're diverging. They're going according to their wish. So it is not possible to make an image over here, right? So what will happen? Everyone is thinking, what will happen? How will we get the image in this case? Yes, Kiran sir, let's check out. How will we get the image? Okay, this is hitting my throat. Oh God. So over here, what is happening? The image is formed over here behind the mirror. Why? Over here in the front side of the mirror, it is not possible to form the image, right? So what will happen? We'll consider an imaginary line. We'll consider the imaginary line. So this, from the reflected rays, what are we doing? We're drawing imaginary lines behind the mirror. So based on that, we can depict the image is formed behind the mirror. So it will appear to form over here. That is behind the mirror. Can you see, guys? The image is formed over here. Now, is it inverted, guys? Is it upside down? Is the image upside down? No, right? It is erect. It is not upside down. It is not inverted. So the image is erect. Since the image is formed behind the mirror, it will not be real, right? It will be virtual. So the nature of the image will be virtual and erect. Got it? Understood? The nature of the image. Now, what about the size of it? What about the size of it? Is it the same size as of the object? The size of the object is like this. And what about the size of the image? Is it the same as of the object? No, right? It is a little bit enlarged. So the size of the object is a little bit enlarged, as you can see here. Got it? Now what about the position of the image? The position of the image is behind the mirror. The position is behind the mirror. So please do mark it like this. Yes, Kiran sir, you can remove the animation. In the case of between P and F, the position of the image is behind the mirror and the nature of the image is virtual and erect and the size of the image is enlarged. So if you want to draw the ray diagram, please do draw it. Yes, Kiran sir, can you please show the ray diagram again? Yes. Yes, sir, can you please place it a little bit left? Guys, please do draw the ray diagram, important, mandatory. Yes, there you go. Please do draw it, important, mandatory. Over here you can see when the ray of light is incidenting the pole, it is making the same angle with respect to the principal axis, right? Then the incident ray of light is parallel to the principal axis. As you can see here, what is happening? It is reflecting back through the principal focus. So these two reflected rays will not make an image in front of the mirror, right? So what we'll do, we'll draw imaginary lines behind the mirror. So practically we'll get the image behind the mirror. So we'll get a virtual and erect image behind the mirror, and the size of it with respect to the object, the size of the image is enlarged. So the size of the image is enlarged. The position is behind the mirror. The nature is virtual and erect. Clear, everyone? Clear? Got the concept? When we are keeping the object, between F and P. We're keeping the object between F and P. In this case, this is how we'll get the ray diagram. Please do note it down. So what is F? The principal focus, and P is the pole. F, principal focus, and P is the pole. Please don't get confused with it. I know some of you used to get confused with P as principal axis. Okay? Please do mark it as pole itself. Everyone is nodding their head. Yes, we used to get confused. P as principal axis. P is supposed to be pole over here. So please don't get confused. So please do draw this ray diagram, guys. Quick, real quick. Let me know if you have any concerns, queries and all. So Mugdha is asking, sir, can you show the table again? Yes. I did not write the last one. Don't worry, we'll show the table again. So please do draw the ray diagram first. Table was supposed to be the homework, right? You guys didn't even try. I told you. Even if you make a mistake, it's okay. We'll discuss in detail in the next session. I told you, right, in the previous session. At least you could have tried. Try to keep the object at or F or at C, between C and F, and try to draw the incident rays of light. And you'll be drawing the incident rays of light according to your wish, right? I know it, but still, you'll get some image. At least when you try, when you make mistakes, you will learn, right? Bhagat Suresh was trying, very good, I appreciate it. He was using measuring values and all, not required, but still, it's good. The image, the ray diagram will look good if you are applying perfect values and all. So write it till 3. Very good, very good. Some of you have partially done. Who was that, man? Suraj has done till 3. Very good, Suraj. Suraj, drawn this ray diagram. Clear? This particular case between P and F. Fine. Between F and P or between P and F. Who was that? Rihan is sharing. Sir, I tried and got fed up with the first one itself. Rihan, are you kidding me? Rihan is like, sir, I tried, but honestly speaking, I got fed up with the first one itself. Unmute Rihan. Rihan, now you feel a way better. Now you feel like it was supposed to be easy. Not tough, right? It's not that tough, right? So, where is Rihan? Please do raise your hand. Yes, yes. Rihan, please do raise your hand. Where is Rihan? Can't see you. Just a second. I need thoughts from you. Sir, I tried. I got fed up with the first one itself. What was that? Now, did you find easy? Now you find it easy, right? When you got the concepts, when you understood all the cases, when we are keeping the object between F and P, at C between C and F, all these different cases in the case of a concave mirror, all the concepts of concave mirror is clear, I guess, for Rihan. Where is Rihan?
Yes, sir, I'm here.
Now you find it easy, right, Rihan?
Yes, a lot easier.
A lot easy. So yesterday or in the previous session when I gave you the homework, you found it very tough, right? You got fed up with the first one itself.
Yeah.
Now you feel better?
Yes, really
Okay.
better.
I'm talking like Rihan is admitted and all, admitted to the hospital. Is it Rihan? You are healthy, right?
I'm healthy, sir.
Okay. Fed up in the sense with the first one itself, you got drained yourself or what?
I just got tired.
You guys just got tired. I was kidding. Stay healthy. So you understood all these examples, all these cases, right? With respect to the concave mirror, image formation in the case of concave mirror. Clear? No confusions?
No confusion.
Fine. So please do reach out, Rihan, if you have any queries, concerns and all. Yes. Hi Sridhya. Sridhya has some queries. Go ahead.
So I see in this last case,
Yes.
the position of the image is behind the mirror, right?
Yes, behind the
So
mirror.
will it be like, how will it be like, it is behind the mirror means?
If the image is formed behind the mirror, will we be able to show it on a screen? Not possible. Got it? So practically we won't be able to project the image on the screen. So that's why it is virtual. It is not real. Got it? It's a virtual image. Got it? Yeah.
Thank you, sir.
Fine. So Sridhar was like, so what will I do? Should I go back behind the mirror and check? No, you won't get the image. So on the screen it's not practically possible to get the image. Okay. So guys, you know, right? Our sessions, not all the sessions, just once in a while or once in a week, we'll have some sessions airing up in our YouTube channel. I hope you guys know about our YouTube channel as well, right? So we have started a new channel for 90 plus middle aged team. So in that particular channel, so certain classes will be coming up. So you will be telling to your friends, right? I'm attending the tuition classes of 90 plus my tuition app. If any of your friends want to check how the sessions will go, or a demo session, or if they want a demo session, it'll be there in YouTube. So for that, please do refer your friends, please do share it to your friends. We have the 90 plus Middle East YouTube channel. In that particular channel, we'll get certain sessions up or aired over there. So we'll get the recorded session over there. So what you have to do, you can show it to your friends. Okay, this is the session which I am attending. Okay, so in the meantime, what you have to do, please do promote me as well. You have to say, Manoj sir, very great teacher, very nice class. All these things you will say, right? So what you have to do, please do share it to your friends. I was just kidding. So in this particular case, what you have to do, please do subscribe our YouTube channel so that you can get the classes in our YouTube channel as well. Not all the classes. Without subscription, you won't get all the channels, all the classes. So certain classes will be airing up in our YouTube channel. So please do access it. So it is shared in the chat box. Those who don't know about the YouTube channel, or those who are not getting it, so please do check out the chat box. It is shared in the chat box. Okay, it is important. Important in the sense you have to refer it to your friends. Yes, Amelia. So some of you were asking for the table, right? So let's go ahead. Please do note down the table as well. Yes, Kiran sir. Yes, unmute Amelia. What's your concern?
So I just checked my textbook, so physics chapter, but control I had before. For object at C, it shows the same drawing I had, same diagram I had drawn in my notebook, but it's different from the one you showed.
Okay, different from the one I showed. The thing is, in your textbook, certain ray diagrams are shown like this. For example, Amelia, right? If we are keeping the object at C, okay, we can draw the ray diagrams like this, right? Okay, but in certain textbook, it is shown as inverted. Okay, for example, with respect to the object at C and at between C and F, it will not be like this. But in the case of rules and all, it is shown like this. They are considering the incident ray of light below the principal axis, and it is reflecting back through the principal focus. So in this case also the rule is applied. The incident ray which is coming parallel to the principal axis, it is reflecting back to the principal focus. But what I've taught you like this, right? I've taught you like this. That is, the incident ray will be coming like this, parallel to the principal axis, and it will pass through the principal focus like this. This is how I've taught you guys. Okay? So these are my artistic skill, guys. So this is supposed to be a concave mirror. So what are we doing? In the case which I have taught you, I consider the incident ray of light on top of the principal axis, right? Then the reflected ray will pass through the principal focus like this. But in the textbook, it is shown like this, where the incident ray of light is coming like this and it will pass through the principal focus. But both are same, right? Understood?
Yeah.
It's just that the inverted ray diagram of it. That's it. Got it? It is not that it is not different, or in the textbook, if the incident ray of light is considered from a different angle, still we'll get the image. If we keep the object at C, we'll get the image at C itself. If we keep the object at between P and F, we'll get the image behind the mirror itself. So it is just that the representation is changed in the textbook. The end product will be the same. So you don't have to get confused with it. Got it, Amelia? Yeah. Fine. Yeah. Sridhaya had some concerns in the chat box. Hi, Sridhaya. Sir. Yes, Judy ma'am, please. Sir, in the first case, why is it diminished and not same? First case, at infinity, Sridhaya. Okay. So in the first case, we'll check it out. So this was your concern. Why is it diminished and not the same? So where are we keeping the object? At infinity, right? If we're keeping the object at infinity, will it be a point size? Will we get the incident rays like this if we are keeping the object as point sized or highly diminished? Will we get the incident rays of light like this? No, right? Since we are keeping the object at infinity, the object will have a particular size. Got it? And the image which we are getting over here is very point sized. So compared to the object, the image will be point sized or highly diminished. So it's not that since we are keeping the object at infinity it will be very big. No, it's just that it will have a particular size, but compared to the object, the size of the image is point sized or highly diminished. It will not be the same size. Got it? How will we get the same size as of the object when we are keeping the object at infinity? It's not possible, right? Unmute Sri there. Yes, yes.
So according to the ray, it will be like inverted and real, okay? But then it can be like the same size and all that.
For example, Sri there. Imagine if I'm drawing the object over here. Okay? So the incident rays of light, if you are considering like this, just imagine. Okay, from the object, the incident rays of light are coming. So, is it the same size over here? This is the size of the object. So the image formed over here, will it have the same size? Because it is focused to a particular point, right? Can you see? All the incident rays are passing through the principal focus itself. So the image is properly focused over here. So we'll get a point-sized image. Got it? Unmute Sri there.
Where will that image be drawn?
It'll be drawn over here. It'll be very small. It'll be very small like this. Very small.
At
Okay.
the focus?
Yeah, at the focus point itself. At the exact focus point, it'll be a very small image. So compared to this size and the size of the object, can you see? Is it the same? No, right? So when we are keeping the object at infinity, it'll have a greater size. But the image form will be very point sized, highly diminished. You can barely see the size of it. That is very point sized or highly diminished. Understood why the image formed is very point sized? Just because from all the incident rays, the image is focused to a particular point based on the rule number 1 which we learned. If the incident rays of light are parallel to the principal axis, it will pass through the principal focus. Got it, Sri there? Yeah, fine.
Thank you, sir.
Yeah. So I hope you have done with the table. Everyone done with this table? Let me know. In the case of a concave mirror, if we are keeping the object at infinity, we'll get the position of the image at f and the nature of the image as real and inverted, the size of the image as highly diminished. And with respect to the position of the object beyond C, we'll get the position of the image between C and F, nature as real and inverted, and size of the image as diminished. And at C, if we're keeping the position of the object at C, we'll get the position of the image at C and nature of the image as real and inverted and size of the image as same size. And with respect to the position of the image between C and F, we'll get the position of the image at beyond C and nature as real and inverted and size as enlarged. If we keep the object at f, we will get the image at infinity and the nature will be real and inverted and the size will be highly enlarged. Now, when we keep the object between p and f, we will get the position of the image behind the mirror and the nature as virtual and erect and the size of the image as enlarged. Got it, everyone? So guys, in all these cases, there is 90, right? In all these cases, the nature of the image is real and inverted, and only in this case it is virtual and erect. And there is a relation with respect to the formation of image and the size of it. So we will learn this relation in the next session. Everyone knows that trick, right? So there is a trick to relate with respect to the position of the image and position of the object. So with respect to that, we can relate it and you can remember. So as to memorize this, I will give you a trick in the next session. Sir, are lenses deleted in this lesson? No. This is just a part of reflection, right? So first we'll learn about the mirrors. So once we are done with the mirrors, then we'll be done with the part of reflection, then we'll move on to refraction. And in the case of refraction, we'll have lenses. Got it, everyone? So we'll go step by step. Got it? So what you have to do, fill the table and try to understand, try to get the relation between the position of the image and position of the object. And with respect to the size of it. So with respect to these changes, with respect to the position and the size, there is a relation. I will tell you this in the next session. So please do stay tuned with 90 Plus My Tuition app. Please do attend the next session. It is mandatory and important. I'm not giving you a homework just because you guys have to find the relation. Okay? You guys have to find the relation between this position of the image and the size of the image. Since this is in this particular session we have discussed the ray diagrams. We are not going ahead with the exam session or Google form link. It's just because we are giving the ray diagrams, right? So it's tough for you. It will be tough for you to draw the ray diagrams in Google form, right? So practically be tough. So that's why we are not going ahead with the exam session since it is ray diagram. I hope you got it. So before we wind up, any queries, concerns, please do raise your hand. Let me know. Yes, some of you are responding, subscribe the channel. Yes, please don't forget to subscribe the channel and share it to your friends. Let your friends know about the sessions which you are attending. So let them know. So you'll be like, yeah, I'll bring all my friends so that I can chill out in the session, right? No. Jemima is already shared to her friends. Jemima is like, yeah, I'll bring my friends and have fun over here. No. So please do reach out, guys, if you have some concerns. Fine. No doubts, right? So if you have understood all the topics which we learned today, give me a double thumbs up to the camera. Give me a double thumbs up to the camera. Let me see. If you have understood all the things which we learned today, crystal clear? Fine. I'm so glad. Thank you and have a nice day. That's all for today. Bye bye, students.